Hey, hi everybody. My name is Mutswana, and I'm a representative of the continent of the Africa. So I want to show you my excellence. Let's get started. So FaceTime. If you have not been here, make sure you go and subscribe to this platform. So every time when I put up a new video or when I upload my excellence, my intellectual property, then you get to learn and you get the notification automatically. Now let's get started. So they say here, the first question they say too small charge. Oh, so this charger here. Okay, let me just make my paint small a little bit because it seems like to be big, so big. Okay, second, and I want to make it smaller a little bit. Okay, so now let's say two small charger means this charger A and charger B. Okay, and charger B, what happened to them? They place in insulated. Insulated is something which does not conduct electricity. Means A is an insulator, so they've been placed in insulated stands also. This stand here is insulator, means no charge is going to be passing through. But the distance between them is 0.2 meter, how they say, as a part shown in diagram below, just like how we see in the diagram. So we see charger A carry -4, just like how we see charger A carry -4 and charger B carry positive. So remember, if they have a positive and negative, means it's going to be force of attraction because they have a different charger. Okay, so now what is the question? They say M is the midpoint, is the point, my apology. M is the point, means A and B, and then we have a point M. But a point M is 0.1 distance from here B to here 0.5, 0.1, and from M all the way to A. If you take 0.2 plus 0.1 means from M to charger A, which is negative, is if you add 0.2 plus 0.1, you're going to get 0.3. That's the distance from A to M. Now, what is the question? That was not part of the question, okay? Because first, before you do, you start your question, you want to make sure that you clearly understand your question. Now they say, that's how they say, okay, calculate the number of electron in a sphere A. But to get number of electrons, very easy, okay? So we have a very simple question. You need to know quantity of charger equal to number of electron times electron charge, and we know, okay, if charger A, if we know the quantity of charger A and we know the charge of electron is always constant, the charge of electron is -1.6 times 10 power -19. You have to memorize this. So what I'm going to do, I want to get number of charger. So I have to make this n the subjects because I want to get number of charger. So if you make subjects means divide by E and divide by E. Oh, so this and this cancel. So number of charger, which is this one here, number of charger equal to quantity of charger over electron. And the quantity of charger we know for A, remember, because they say calculate the number of excess, number of electron, excess in a sphere A. So now we say quantity of A, of charger A, which we have, equal to -1.4, this one here, negative, because this charger A, sphere A, -4, sorry, times 10, 10 is what? -6 coulomb over, this is coulomb over electron. Electron, we know electrons always is constant. Electron is -1.6 times 10 power -19. You see what I'm saying? But this also what is the coulomb, okay? So what we're gonna do, we simply cancel, okay? Coulomb and coulomb cancel. Take that one, plug in the calculator. If you plug in the calculator, it's gonna give you number of charger equal to 2.5 times, means plug in the calculator. These are -10 times 10 power -6, and then 1.6 times 10. And this is gonna give us 2.5 times 10 power -13. What? Electrons, because they say calculate the number of electrons. So this is going to be what? Our electrons. Oh, so this is going to be number of electron in a sphere A. See? But if they ask for B also, you could have done the same tricky. Means we could have said, oh, so for B, if it was for B, but this is not part of the question. So if it was for B, we could have done something like saying we could only replace quantity of charge now. It had to be for B. Let's say for B. See? So we want to say quantity of charge for, but it's not part of the question because in the question they say only for sphere A. Now what I'm saying is let's assume for B. So if you choose for B, and then I could have said this is charger for B. So I'm going to say this is going to be 3 times 10 power -6 what? Coulomb. And then you plug in the calculator, all this, and then it was going to get number of electron for B. You plug in the calculator, and then it was going to get your answer. Okay, now let's go to 7.2. For 7.2, see, 7.2 is way easy. Okay, now they say here, question 7.2, say calculate the magnitude of electrostatic what? Force or electrostatic force. So they say of what? Of a sphere A on sphere B. Oh, remember, this is positive charge and this is negative charge. So the force between them is going to be force of attraction, because negative and positive. You know, when there's a negative positive, means it's going to be attracted to one another. This sphere is going to be attracted to one another. So we want to know that force of attraction. We call it electrostatic force. So electrostatic force, we always, but of A and B, you can say F of A and B. Okay, let me give a definition first. Electrostatic force between two charger is directly proportional to the product of the charger, means let's say this charger 1 and this, let's say charger 2, over the square of the distance between them. Means you take the product of the charger and you divide it by the square of the distance between them. So we say electrostatic force between the two charger is directly proportional to the product of the charger, means charger 1, charger 2, and then divided by the square of the distance in between. But look, so now if you remove this proportionality, is going to be electrostatic force equal. When you remove the proportionality, you replace with a constant, which you call it what? Electrostatic constant, K. And then you multiply, means this one is gone, and then you put your equal sign, and then you replace with, and then you put equal, and then put electrostatic constant K, which is given, we know the value, times by charger 1, charger 2, means the product of the two quantity of charge over let's call the distance in between. So that's how you get electrostatic force. So now for this case here, 7.1, they say, excuse my apology, calculate the magnitude of electrostatic force exerted between the sphere A and B. Oh, so electrostatic force of sphere A and B equal to K times quantity of charge of A, quantity of charge of B over the distance between A and B. You square that. This means the distance of A and B. What you do? You square. So we have all the information here. So what we're going to say is way easy, because I'll simply say electrostatic force A and B equal to K. We know electrostatic constant is known. Most of the time they give to you. Okay, electrostatic constant is always equal to 9 times 10 power 9. You need to memorize, but most of the time in exam they give to you, but me, I know I memorize. So this electrostatic constant is going to be 9 times 10 power 9 times quantity A. Quantity A, we know. What is a quantity A? Our quantity of charge A equal to this one, negative 4. So say negative 4. So let's put this in a bracket. Another bracket. So, but look, if you find an electrostatic force, most of the time, don't put the negative, don't put the sign for electrostatic force. Just take that charge at the quantity of charge. So simply ignore that negative. Okay, only for electrostatic force. Okay, and then I'll show you next when you want to put the sign, when not. But when you find the force, just ignore that negative. Okay, ignore that negative, and then take your charger, which is 4. And then what we do, we multiply, means this charge here, multiply by 10. Excuse me. Okay, 4. And then you multiply this one here. Multiply by 10, multiply by 10, 10, negative 6. And then we multiply by charge B. What is charge B? Our charge B equal to 3 times by 10, what? Negative 6. In the bracket over the square of the distance between them. So distance from A to B is 0.2. And make sure it has been meter, in meter. So if it's centimeter, is in millimeter, make sure you change it to meter. But we're very lucky enough now they give us the distance in meter already, because that's a unit of distance. So it's going to be 0.2, and then we square. Why do I take 0.2? I don't take 0.1? Because we want to get the electrostatic force between A and B, and the distance between is 0.2. So now you're going to say electrostatic force between these two equal, take your calculator, plug in the calculator, and this is going to give us 2.7. 2.7, but since it's the force, so the unit is going to be Newton. See, the unit is going to be what? Newton. So now we want to go for 7.3. Oh, so we have electrostatic force between A and B equal to 2.7 Newton. Okay, so let's erase everything. So I'm going to have to say the electrostatic force between A to B is 2.7 Newton. So for that, thank you for your patience just now. So let's just write a little bit here because you're going to come and use these things, okay? Electrostatic force, okay, let me write here. Electrostatic force of A and B is 2.7 Newton. Now let's go for 7.3. Describe electric field. Electric field, okay. Excuse me. These are field, okay? Okay, let me write here. Electric field. Okay, let me give example. Remember, there's a force of attraction here from sphere A to sphere B. Okay, let me explain in terms of the magnet and they'll come to electric field. Let's assume you have a magnet here. Let's say this magnet have a north and this has a south. So what happened here? Means the flux, but this has nothing to electric field and then I explain to electric field, okay? The flux is going to be moving from north to south because remember it's going to be force of attraction here, right? Because there's a different poles of the bar of the magnet. Means the magnetic flux is going to be moving from north to south always. So this is magnetic flux. This one is, but this region here we call magnetic field. Magnetic what? Field. But now this region of magnetic field, but this magnetic flux. Now let's come to electric field. So for electrostatic now, remember we have what? We have a field here, okay? So meaning when they talk about electric field, mean this field here whereby there is a force of attraction of negative sphere, negative charge and a positive charge, because here is where the attraction happened. And for this case, attraction because they have a different charger. But if they have the same pole of the charger, let's say this is positive and this is positive, means they're gonna repel one another. Means they're gonna say, go there, I'll go the other side because they have a same charger. You see? So this region here, we call it what? Electric field, because it's where force of attraction or repulsion appear. So now we're going to say this is a region in a space where electric charger experience that electric force. But you can simply just check in the books or, so let me just give it to you. So electric field is the region, how they say, is the region. Okay, this is a region in a space, because this is in a space. In a space where in which bracket you can say, or in which, where, or you can say in which an electric what? Electric, in which an electric, or if you don't want to say an electric, you can say charger, bracket, charger. You can write exactly how I write. An electrical bracket charger experience an electric force. Experience a electric, or you can say bracket force. Write exactly and you get all your marks. Now let's go to the next question. Let me go quick now, okay? Next question is way easy. So let's represent the continent of Africa in an excellent way, okay? Now let's take out the magnitude of net electric field. Okay, you see now, this is electric field. So for electrostatic force, what did I tell you? If you find electrostatic force, don't bother much about the sign. You remember that? But for electric field, involve your sign. This is a little tricky. Like somebody could have done another way, but this is my trick and it does work for me, okay? Just a disclaimer, okay? So if it worked for me, give it a try. It might work for you. So when you find the electrostatic force, just ignore those signs. But when you go for electric field now, involve the sign. How do you get an electric field? To get electric field is easy. The formula say electric field equal to electrostatic constant, and then take your quantity of charge over the square of the distance. That's how you get electric field, which you represent using the letter E. Okay, now, so which electric field they want? They say calculate the net electric field at point M. Okay, let me take a little. When you say net, is something extra, like a net force, net electric field. You see what I'm saying? Because some people don't know what is net. For example, This has nothing to do with business, but I want to explain something. Let's start you start your small business with, let's say, $10 or £10 or 10 shillings. Let's say this is African shillings here, 10, or rand, South African money, or African shillings. You start with 10 rand, and then after 2 days, you have a 30 rand or 30 shillings, which is very common African money. So now the net profit or something net means take what you have attained minus what you have started with. So you're going to have a 20. So 20 is the net. Okay? So net is something that extra, which is going to make you, let's go to the next level or whatever. Okay? So now when you come to this one here, if you say we want to get net electric field at point M, what does that mean? Means if this point M, I'm going to have to find electric field of A with M and the electric field of B with M. And then after that, let me add them together, or let me find the difference of them together. That's going to help me to get the net. See? So now, because they say of at point M with A first, and then M with B, and then let's find the sum of the difference between them, and that's going to be our net. Now, so let's get electric field of AM first. So electric field of AM is going to be equal to constant K, is going to be equal to constant K times quantity of charge of A, because electric field, you only take one charge, and then over the distance between them. What is the distance between them? The distance from A to M equal to, look, 0.2 plus 0.1 equal to 0.3, and all of them, they have to be meter. So if this one is in centimeter, make you change to centimeter. But for now, we're lucky, so it's going to be 0.2 plus 0.1 is going to be 0.3. So let's say distance of AM, let's say here AM square. So we can simply say electrostatic force of AM equal to constant K, we know, equal to 9 times 10 power 9 times quantity of charge A. So now in the electric field, do involve the charge. They'll say, oh, you say we should not involve. No, do involve your charger. It's very, very crucial, very important. Excuse me, sorry. So we're going to involve our charger. What is our charger? Our charger equal to -4, charger A, right? Times 10 power -6 what? Coulomb over distance between A and M, we say 0.2 and 0, because from the here all the way it's going to be 0.21, 0.2 together, 0.3. So what you do, make sure you square. And in your solution, write everything, okay? That's how you get the marks, okay? Don't skip. So electric field of AM equal, in the calculator, this is going to give you -4 times 10, 5 Newton per coulomb, -1, okay? But remember, since it's negative, you can simply say, if I don't want to write like that, I can say, okay, electric field of A to M. If I remove this negative, and then I can say 4 times 10, 5 Newton per coulomb, which is the unit of electric field, and then you can say to the left. Man, what you mean about that to the left? Because negative, we know in a number line, in lower grade, we learn if it's negative means something is on the left. Positive means to the right. So if I decided, let's remove the negative, then I can say to the left. Or if I don't want, I can leave my negative how it is. So now we have electric field of what of? We have electric field of what of? Of AM. So of A to M all the way. Now let's get electric field because we want to get net of what of? BM, and then we're going to find their sum or the difference to know the net electric field. Okay. So now let me write my electric field that I got here on the side, because we're going to come and use it. Excuse me. On your solution, write everything in a good order, okay? Do not write, because my space is very limited, that's why. So I'm going to say electric field of AM equal. So we're going to say 4 times 10 times 10, 5 Newton coulomb -1. Don't forget your negative, right? Say negative here, negative. Okay, cool. Now, let's find the electric field now of what of? BM. Okay, easy. Electric field of BM. So now we're going to say electric field of BM equal to electrostatic constant times of b square over square of the distance of b to m. But what you do, you square, means from b to m, and then constant times quantity of charge of b, because we say electric field equal to k quantity of charge, you square times the distance square. See, only one k and oh my god, sorry, I made a mistake here. Okay, so we say k. Oh, sorry, I did something wrong here. My apologies. Sorry. We say electric field equal to k quantity of charge over square of the distance. So quantity of charge now is b. Okay, there is no square here. Okay, it's just a k quantity over square of the distance. Okay, that's electric what? Electric field. So we want to say now k quantity. Let me write down a little bit because it's going to be messy. Okay, electric field equal to k quantity of b, for this case b, no square here. What am I doing? Okay, no square there. I'm sorry. Over square of the distance. With the distance is going to be from bm. It's going to be bm, but you square your distance. Now we go. So we're going to say now electric field of what of bm? K we know is 9 times 10 power 9 is a constant. That's what I say. I know. Bracket times. Okay. Quantity of charge B. Quantity of charge B we know is, let me just come 3, this one here. 3 times 10 power negative 6 bracket, but it's positive, so I don't have to write. Over square the distance. What is the distance? Is 0.21 here. It's a distance here. 0.21, 0.21. So what you do? You square. So now you can simply plug in the calculator, and if you plug in the calculator, that's going to give you 2.7 times 10 power 6 Newton per coulomb, but I put your negative. So this is electric field of B to M. Oh, 2.7. So we also have electric field of B to M. Okay, so then we finish up. So we can get the net because we have electric field of both. Okay, we have electric field of both. So net electric field, look at it. This is very, very crucial. Okay, let me write my electric field now. Electric field of BM first. Let me equal to 2.7 times 10 power 6 Newton coulomb negative 1. Okay, now, so let's get the net electric field. So net electric field. Okay, look. So if you look careful, meaning this one is to the right because positive means this is to the right, but the face one, AM, means from A to M will go to negative, means it's to the left. You see what I'm saying? This is to the right and this is to the left. So what you do, you add them together, add them together, add them together. This is bigger, right? This is bigger. Take the bigger one minus smaller, or you can simply add them together. See? So I'm going to take 2.7, so I can say electric field of BM minus electric field of what of AM. But we know AM is negative, so it means it's going to become positive. Or, so we're going to say this equal, or the simple way, look, it's like say, take this bigger minus, but remember, this one also has this has a minus already, so it's going to become what? Plus. See, slowly. This electric field of BM is 2.7 or whatever you have, and then you minus that. So we're going to say, look, let me say 2.7 times 10 power 6 minus, but the other one of EM it also had a negative. So put yourself in bracket always, which is going to be 4 times 10 power 5. So this is going to give us what? Positive, negative, negative. Or the base way, just add them together. Simple like that. So say electric field of BM plus electric field of AM. So this is going to give us, let's add them together. So we're going to say 2.7 times 10 power 6 plus minus, because this has a minus here, the one to the left, 4 times 10 power 5 Newton Coulomb. Oh, you don't, we're going to write to the end. Okay. So net electric field, if you add them together, this is going to give us 2.3 times 10, 2.3 times 10 power 6 Newton Coulomb -1, because that's the unit of electric field. So we have our net electric field. So net electric field we have already. Okay. Now let's go to the next one. So now we know the force between electrostatic force between A and B is 2.7. See, and the net electric field from M to A and B we already have. Now let's go to this other part. We're not done with the question now. We're going to go to this one right here and finish up 7.3. And finish up 7.5 and 7.6. We're not done yet. Okay, now, so if you come here careful, they say, look, let me show you something here. Okay, let me go back a little bit. And let's say, very, very important. We're finished now. We almost finished. Okay, look at this. If you can look careful, question number 2.2, look, it's almost the same. Okay, this is B and this is A. Oh, so it's almost the same and 0.2. You see the distance here is 0.2. Oh, so it's the same thing, means A and B, the distance is 0.2. And then, okay, now let's see. Now they say, and then they connect D here. But you need to read, right? This is not come from mouth. A charge A and B and another charge sphere is now arranged along the rectangular axis. Oh, so they added another one here, which is D. Like, look, these are A and B, so they decided to add here on top. Like, okay, let's add here D. You see? So now they kind of scratch this. They don't need this. That makes sense a little bit. See? So now they realize the distance from D to A is 0.5, where charger D is added. Okay, so 0.15, and the distance here we had already given. So there is another force which comes here as a net force, because they say here a sphere A now is going to experience a new force, because look, remember now the force is going to be different because this stuff is going to be pulled or attracted, because for now we don't know the charge of D, but roughly it could be positive, because we know something up meaning is positive. Anything which is on top or up is positive. Down, negative. See? You see what I'm saying? So we're going to say, so now we're going to say, so now what do they want? They say, is the charge sphere D positive or negative? No, come on, it's positive because it's on top. See, it's on top. Or say positive. So the answer is going to be positive. Now, for the second one, they say calculate the magnitude of a charge on a sphere D. Okay, magnitude of charge on a sphere D. So what we have to find, look, magnitude of a charge on a sphere D. What is 7.69? 7.69 is the net what? Electrostatic force. Net electrostatic force. But whenever we say net is something come from the two things. So any force which is experienced in A is because of the result of D and the result of B attached to it. It's not attached like is has influence toward A. So what we're going to say, we're going to say if now they talk about electrostatic force, net electrostatic force. Oh, remember what we did about net electrostatic field? But now electrostatic force. So okay, force net at A equal, but any force at A is influenced by force AB and force AD, because remember here is going to be another charge. That means the force is going to be this side and this side. So let's find AD and AB. Those two forces and those two forces, we're going to see how they're going to influence those two things. But we say when you find the net force, what we do? We add. So I'm going to say force. So force net square always. Why we square? because this is in a rectangular form. Whenever you have a rectangular form, if you want to get force of net, you say F net square, and they say force of here to the another charge, and then force of here another charge. Then you add them together. Add them together, just like how we did before. You add them together, net force. So we're going to say now force of A with the D square, and then you add the square, plus force of A with the B square. And this is going to help us to get the net force of that A. See what I'm saying? That's going to help us to get the net force of that A. So it's easy. So what I'm going to do, I'll simply say, let me find the net force of AD and the net force of AB, and then I'll add them together at the end. Okay? Okay, now let's do that. So for that case now, we can simply say, let me find the net force of A. So force of, force AD square. So what is AD means from here to there. So I'll say, okay, K quantity of A times quantity of D over square the distance square. Square of the distance between means distance from A to D. So square of the radius of AD means square of the distance. Distance what? AD. But like I told you, whenever you deal with the forces, just ignore the sign. Unless if electric field. But somebody could have include the sign. But this is my tricky. For me, it does work. Maybe for you, it might not work. So see what works better for you, okay? So I'm going to say this same say electrostatic constant. But for electric field, do involve. So electrostatic constant is 9 times 10 power 9 means this one. Now charge A. Charge A, do we know? No, we don't know. But look, I think so went all the way cycle. I was not supposed to waste a lot of this. I could have simply say, excuse me, we know force net at A because it says sphere A is going to, the net electrostatic force experience is this. So they have given us a net electrostatic force. So there was no need for me to find this because we know that. So what's the net electrostatic force? 7.69. Oh man, that was dead. Okay, dead. Okay, 7.69. But what we do, we square equal. But force of AD, do you have force of AD? No, we don't have. But remember, from A to B, we did calculate already, which is just this one. From A to D, we know the force from A to D. A to B, my Paul, A to B. What is A to B? 2.7. Oh, we did find that phase. Yes, because of the same diagram. So what we're going to do, we come back here, okay, and say force AB, I don't know. So I'm going to say force of AD, I don't know, plus force of AB, I do know, 2.7, but what you do, you square. So now you can do normal simplification, and then now take this one, which is 7.69 square, minus that 2.7 square equal to f of a d square. What you do, you square root, and then what you do, you square root. This and this cancel. So force of AD, okay, take a calculator, plug all of these, and then with this and this cancel. So force of AD equal, so this is going to be 7.2. Plug in a calculator, all of this is going to give you 7.2. Oh, Newton. So the force of AD equal to 7.2. Oh, so the force here between A and D is going to be A and D here is going to be 7.2. Wow. So what do they want? We're not done yet because they didn't just ask force of AD. Now they want the magnitude of sphere D. Oh, if I have a force to get the magnitude of another sphere, it's easy because I want to say, look, now the electrostatic force of AD, which I just obtained, equal to electrostatic constant times of charge of A. So I can say charge of A times charge of D over, oh man, let me write my A good. Charge of A times charge of D over the square of the distance. What is the square of the distance of AD? Ara AD. So it's a distance which is Ara AD square. So we can plug it in. So we know this force we just get it now, which is what is 0.72, and K we know is constant. Charge A we know because they give us before, we know from before. Charger A is 4 point. Remember, this is not net. Charger of A. Okay, now let's go. So now I'm gonna simply say charge of AD. We just got it now. 7.2. Constant we know. 9 times 10 power 9. Quantity of A. We know quantity of A. Charge of A, which is what is this one here. 4.10 410 power negative 6. But I have to ignore negative because especially when you deal with a force, like I say, okay, just ignore the negative. Don't let it stress. If you deal with a force, I'll say it again. But for electric field, involve your sign. So I'm not gonna write that negative. I'll just simply say 4 times 10, 4 times 10 power negative 6. But now we want to get what? Charge of D. That's what we're looking for. This one here. Magnitude of charger at D. See what I'm saying? Magnitude of charger at D. So now let's get it. Let me write good, man. Let me write this good. And then what we do, we divide by distance between, we have 0.5. 0.15 square. So what we're going to do here, you can simplify and finish up our equation. So now I'm going to say 7.2 times that. So I can cross multiplication. I can say this over 1 cross multiplication. So it's going to be 1 times all this stuff. It's going to be 9 times 10 power 9 times 4 times 10 power negative 6. Charge of D we're looking for equal 7.2 times 0.15 because we cross multiplication. This with that and this equal to now because that one was 1 times all of this. Now 7.2 times 10 7. Times, no, it's not 10. Oh, what am I doing? Times what? 0.15 square. So I can simply divide here and divide there by this one here, which is 9 times 10 power 9 times 4 times 10 power negative 6. This and this cancel, and now we divide by the same thing here. 9 times 10 power 9 bracket 4 times 10 power negative 6. This and this cancel, so we say quantity of charge of D equal, plug in the calculator, and that's going to give a final answer equal to 4 times 10 power negative 6 coulomb, because this is a charger. So the charger of D equal to 4, finally, here, quantity of D, 4 times 10 power negative 6, what? Coulomb. And look, so you see some of you, sometime you might be new right here, okay? So that's the end of the question. Please come right here, show me some love. You see, comment, subscribe here, okay? Comment, subscribe. You see, I love my brother and sister from the continent of Africa. I love everybody across the planet Earth, okay? But like I say, I'm a true representative of the continent of Africa, okay? Coming represent the continent, represent the excellence of what we got and what we can offer to the world. And you can check here, man. This is my old picture when I was a baby. See right here? That's me right here. I was in 4th grade, I remember, with a Ras Kisia. That's a Ras Kisia. That's my man. And these are my friends, my younger friends. When I was young, all these are my friends, man. You know? All these are my friends. So, and this is right here is me when I was a baby. That's my mom and her friends. That's old school black and white picture. So come subscribe here. You know, I love my brother and sister from the continent of Africa. My name is Mtwana Nkosi. You can also check my other channel under the links below, and you can see what we do for the community. Apart from this, we have a feeding program, feeding, helping back the community. They always say you can share what you have. You don't have to be wealthy or billionaire. You can give back with what you have. So I started the initiative to raise awareness for giving back the knowledge, skills, see, food, you know, inspirational, and anything that you can give back. Because if we're not going to do that, and who's going to do that? We can't always wait for the other people to do for us, okay? We, as a continental brother, we can't constantly ask people for aid, helping us, save us. We the solution of our own problem. Because if you grew up with that, and then you become mentally disabled because you constantly believe that you cannot be solution to your own problem. You just wait for the people to do for you. Or see? So please come right here, subscribe to this my channel. This one here, Mutwana or Bantu Academy. If you have not yet subscribed, click here, like, share, and then also I love my continental brother. And then go to other channel called Mtwana Nkosi. Mtwana Nkosi. Click there, subscribe, see what I do for the community, okay? Mtwana Nkosi in another channel is called Mtwana. All my channels have to the Mtwana, or you can check in the link below. Another channel is called, so make sure you check Mtwana Nkosi, and another one is called Mtwana Varongwa. Mtwana Morongwa. 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 Check both channel, or if you cannot find or you can't have a problem, look under the link below. I'm going to touch all the video. So come to this channel, show me some love. If this video was very helpful, please leave a comments, because comments is very important, because I get to know like, hey, there are people need my help. There are people, because if you don't give me feedback, then maybe I might think, oh, maybe this video is not helpful. But if it does that, if you do that, means it tell me like, oh, there's a people who want my presence. So leave in the comments feedback to tell me, hey, Mutwana, this video was real helpful. Or maybe you can prove doing that. Oh, wow, I love this, Mutwana. Oh, I didn't know that you love us, Mutwana. You see, because I got people following me from all across the globe. People from Mississippi, from Louisiana, especially my brother and sister from Louisiana, Chicago, California, Tennessee, South Africa, Tanzania, Nigeria, Congo, Ghana, my Nigeria brother, Sierra Leone, Senegal, Egypt, Morocco. Come here, show me some love, leave comments below, and peace in the mouth.